So, autonomous AI agents. They're not just a future thing anymore, they're here. We're talking about AI that can actually do stuff, run complex, multi-step tasks all on its own. But as we start to hand over the keys to our software, this huge question pops up. How do we really know we can trust them? Let's get into it.
It seems like such an obvious question, right? If you ask an AI agent to do something and it does it, well, that's a win. But what if looking only at that final result is actually one of the most dangerous ways to judge how well an AI is performing?
I mean, think about it this way. A student gets a perfect A+ on a test. Looks amazing on paper. But what if you find out they cheated on every single question? Suddenly that A+ is meaningless, right? It doesn't prove they know anything, and it definitely doesn't mean you can trust them. Well, it's the exact same thing with AI agents. They can give you the perfect final result, but behind the scenes, they might have used an unsafe shortcut or even just made the whole process up. The bottom line is, we have to look at their homework.
And this gets us right to the heart of the problem. As it stands, the way we test most AI agents are benchmarks. They have 3 huge blind spots. And these blind spots are keeping us from seeing what's really going on under the hood.
Okay, so first, our grading is what you'd call trajectory-opaque, which basically just means we can't see the path the agent took. We only see where it landed. Second, we tend to test safety in these neat, tidy, isolated boxes. But that's not how the real world works. We're not testing what happens when the agent is under pressure to get a task done, and that dangerous shortcut starts to look really tempting. And finally, we're testing them on single skills, like a 100-meter dash. But the real world is messy. It's a triathlon of text, images, and video all mixed together.
So how do we fix this? Well, a group of researchers has put together a whole new playbook, a complete evaluation system that's designed from the ground up to close these gaps and finally build a real foundation for trust.
This quote right here, it just nails the core idea. We can't just take the agent's word for it. It's not enough for it to say it did the right thing. We need cold, hard proof of what it actually did, from sources it can't manipulate. It's the difference between asking someone if they paid a bill and actually seeing the receipt for yourself.
And here's how they do it. It's a really strict 3-phase process. First, they set up a completely clean, sandboxed environment. Then, the agent gets to work inside it. And this is the critical part. While the agent is working, there are no graders, no answer keys, nothing. It's just doing its job. It's only after the agent is completely finished that the third phase, judge, kicks in. That's when the auditors step in to look at the evidence. This separation, this firewall in time, is absolutely key.
So what evidence are these auditors looking at? Well, this is where it gets really smart. They don't just rely on one source of information. No, they triangulate the truth by collecting evidence from 3 completely independent channels.
First up, you've got the execution trace. This is basically the agent's diary. It's the step-by-step log of what the agent thinks it did to solve the problem. This is its side of the story. But then you get the second piece of evidence, which is way more objective, the audit logs. You see, every time the agent tries to use a tool like an email server or a database, that tool keeps its own secret log. This records what the agent actually did, giving us an external, verifiable record that the agent can't touch. And for the final piece of the puzzle, you have the environment snapshot. After the agent is all done, the graders take a complete snapshot of the system's final state, every file, every piece of data. This is the undeniable physical proof. So when you compare what the agent said it did, what the servers saw it do, and what actually changed, well, suddenly you have a complete, bulletproof picture of what happened.
Okay, so what happens when you actually start grading agents this way? Well, the results are, frankly, a little terrifying. This rigorous approach uncovers critical failures that were completely invisible before. Get this, 44%. Just let that sink in for a second. That's the percentage of safety violations that traditional AI judges, the ones that just look at the final answer, completely miss. Nearly half. And we're not talking about small slip-ups here. We're talking about agents trying to access forbidden files or use tools in dangerous ways, all while telling the user everything was fine. And this chart just lays it all out. The new hybrid pipeline, the one that uses those objective audit logs, it catches 100% of the violations. Every single one. But a standard LLM judge, it only catches about 56%. And why is that? It's because the agent is basically a smooth talker. It gives these plausible-sounding but totally false explanations. And the LLM judge, without the hard evidence from the logs, it falls for it.
This new method also lets us tease apart 2 really critical ideas: potential versus reliability. So, Passat K measures peak capability. In other words, out of, let's say, 3 tries, did the agent get it right at least once? That shows its potential. But Pass K is different. That measures reliability. Did it succeed every single time in those 3 tries? That shows its consistency.
Now watch what happens when you throw a wrench in the works, like simulating a 20% error rate for its tools. The agent's peak capability, its potential to succeed at least once, stays incredibly high, up at 98%. But look at its reliability, its ability to get it right every time. It just tanks, plummeting down to 76%. This shows that an agent can look like a genius on a single try but be totally unreliable in the real world. That gap is exactly what we've been missing.
And another huge eye-opener from this, agent capability isn't just one single thing. A model that's an absolute wizard at handling text-based tasks might completely fall apart the second you ask it to understand a video or build a web page. In fact, the model that did best on general tasks was only second best on multimodal ones, and the other way around. We can't just ask which model is the best, we have to ask the best at what.
So, let's pull all this together. What does this all mean for the future, for building AI that we can actually genuinely trust?
If you remember anything from this, remember these 4 things. First, how an AI works is just as critical as its final output. The process matters. Second, an agent's peak capability, its potential, is not the same as its reliability. We have to measure for consistency. Third, to get a real picture, we have to test these agents under realistic pressure with things that can go wrong. And finally, the foundation for all of this, the only way to build trust is to build for auditability. We have to be able to audit the entire process.
This new approach really does give us a path forward, but it leaves us with this one big question to think about. As these powerful agents start managing our calendars, analyzing our business data, and just becoming part of our daily lives, the real challenge isn't just going to be making them smarter. It's going to be about making them trustworthy. It's not about getting the A+ anymore, it's about showing the work.